Okay, so we're going to do average rate of change, and they've given us this equation, and we've drawn a decently accurate sketch of this. We got our two x-intercepts and a vertex of this quadratic, okay? The first question, we'll zoom in so it's easier to work with this stuff. The first question asks us to find the average rate of change when x is greater than or equal to 2 and less than or equal to 4. Okay, so what they're essentially asking us is, in this case, if we look at our quadratic that we have, and we're going to have to extend it. We'll extend it up to here for now, okay? They're looking at the average rate of change. And remember, this isn't linear. What's actually happening here, this is probably curving up more. So just to give us a better idea, I'm going to curve it a little, because parabolas technically curve as they start to go up and up like that. We're looking at between 2, so let's estimate here's 2 and here's 4. Okay, well, if you notice a straight line from here to here won't exactly follow the parabola, right? Because it's got a bit of a hook to it. So what we're going to do is we're going to find the two extremes. So in this case, the extremes are being our x value of 2 and our x value of 4. And we're going to find our actual y coordinates for it. So we'll see if this is actually close to what we've sketched here. And we're going to plug those values into this equation we have above, the 4x squared minus 5x plus 1. And technically they gave it to us in function notation. It was g at x. So this function g. So we take our first value, 2, and we're going to plug it in for both of the x's in this equation to find our y. So we're looking for g at 2. Okay? Does that make sense so far? And what ends up happening is we replace all the x values with 2, kind of like what we did before to find the vertex of this. This becomes 2 squared is
4
times 4?
16.
Good. 5 times 2?
10.
Good. What's this all going to add up to?
7.
That's right. Good. So the very first thing, what we've discovered is 2. We weren't that accurate. It really should have been more up here. So we can actually sketch, partially sketch our graph using this. Okay. We had the two x values and we estimated the rest. At 2, we're actually at 7. Okay. So this parabola needs to start going up like this, which really means at 4 we're probably going to be off the chart. We'll find out. But that coordinate right there, we have a coordinate at 2 and 7. That's what we just found out. And then we're looking for the same idea, except 4, and we're plugging it into the equation. So that's going to give us g at 4. Exact same idea. 4 times 4 squared minus 5 times 4 plus 1. All right, 4 squared is 16. Do you know what 16 times 4 is? Let's give you a hint. 16 times 4. Yeah, it's 64. Okay? Minus 20 plus 1. So, yeah, that's like 21. Think of it like this. 44, I think it's 45. It should be. Is that right? Take 20 off that. 44 plus 1, 45. Yeah, okay. So our other coordinate 4, so we were way off. It really needed to go much, much higher, right? So let's just say we're at 4 and 45. Okay, so really that's a huge jump, what's happening there. So our graph doesn't quite show that. If we put it into tens, maybe we could do this also. Let's kind of redraw this to make sense of it. Let's say this is, we'll make this a chart by tens. Okay, so we know our vertex is really something down here, and then at the value of 2, we were at 7. So 7 in this case is actually going to be like down here, and 4 at 45 is going to be like this. So we have some parabola that's kind of going like this, then heading upwards. Now again, you notice how it started to curve, right? Because we're looking for average rate of change, we're essentially looking for the slope between those two major points. So we're looking for the change, or the rate of change between the two. So rate of change is essentially just the change in your y, so that triangle means change, divided by change in your x, okay? Which is slope. Change in y over change in x is known as x2 minus x1 divided by, sorry, y2 minus y1 divided by x2 minus x1, which is also known as rise over run, which is also known as slope, which is also known as m in y equals mx plus b. So many of these things are actually equal, okay? So, since we have our two coordinates, and we can decide which coordinate to call which, we had one at 2 and 7, and the other one at 4 and 45, correct? Mm. Since we have those, well, you know what? I'm going to call this my x1 and my y1, and this will be my x2 and my y2, okay? Either way, we'd end up with the same slope, whether I called this coordinate 1 and this coordinate 2, or vice versa, okay? So now that we have that, we go to plug in. Well, our y2 is 45. So we get 45 subtract 7 divided by 4 subtract 2, okay? And this is going to be our m. That's how I'm going to represent it. Okay, 45 subtract 7 is going to give us 38 divided by 2. It's going to give me, I think, 19 over 1. Yeah, 19 over 1. Okay, so that's technically our slope, 19 over 1. So the rate of change, and they didn't give us a unit. No, the rate of change is 19. So this thing's going up 19 for every 1 it moves over. Okay, so that would be the slope between these 2 points. The average rate of change is 19. Okay, and then what we're going to do for each of these, we have to kind of carry out the exact same process of plugging these numbers into this equation, getting the coordinates, and then plugging into the slope formula for the coordinates.
Okay.